Well, hey everybody, I am Ryan, and this is
Doug.
And this is
Signal Paths.
What's our topic today, Doug?
Crossovers and the parts within them.
The crossovers and the parts within them. So, this kind of came up because I was asking you questions about when you do speaker design, you have to come up with impedance ratings for your speakers. So you have like a 4 ohm impedance, you have an 8 ohm, and any other possibility.
Right.
Most of them are going to stay within the 4 to 8 ohm range, but there are 16 ohms as well.
Yeah.
But anyway, so that kind of stirred our conversation, and so we're going to talk about that and how do these components interact with the drivers to change impedance,
Sure.
but also how do they interact with the drivers to make the drivers do certain things. So,
Well, yeah,
cool.
when it comes to a driver, when they say nominal impedance, that means that's the impedance that they spec the driver at, and that's
Okay.
that's the predominant impedance of the driver.
Okay, cool.
But a driver is not a linear impedance
Okay,
thing.
cool.
So this is a woofer that I use in one of my designs.
Okay.
And if you notice that spike right there, this is the impedance
Yeah.
right here.
So we're talking about the bottom blue
Yeah.
line.
That right there is called the resonant frequency.
Okay.
That why the impedance goes up to almost over 100 ohms
Yeah.
is because that's the point and where that driver is working the least but
Okay.
putting out the most output.
Okay.
And that is the natural resonance frequency of that driver.
Well, that sounds pretty crazy. Like it's 100 ohms, over 100 ohms, and yet somehow we're going to get an 8 ohm driver. Like
Well,
how in the world does that work?
If you look down here, it is 8 ohms through a good portion of its band.
Okay.
That just happens to be the resonant frequency.
Okay.
So an amplifier at that resonance frequency, it's doing a lot of work, and the amplifier is not having to do a lot of work.
Does the amplifier even register with that high of an
Sure.
impedance? It does. Okay.
Yeah.
Cool.
Yeah, it's still powering things. The low impedance is just, like I said, it's a nominal.
Okay.
It's at certain points in the frequency band. If you notice, that woofer is pretty, it's relatively smooth up to this point, and then it goes a little ragged.
So let's talk about these top lines. We've got a red, a green, and a blue.
Yeah.
What's going on with this?
Okay, so when you measure a driver, most measured drivers from the factory come with a measurement right on axis, then like a 15 degree and a 30 degree.
Okay, so when we're talking about that, we're talking about my speaker is right here. I'm on axis if it's here, but if I move over here,
Correct.
I may be 15 degrees off.
Correct.
And then there's
Well, what
Right.
happens here for a woofer, and this is exactly why woofers don't use woofers above a certain frequency,
Right.
or any driver above its intended frequency, is because what they call beaming.
okay.
Beaming is when the driver goes from being smooth at every axis like this.
Okay, so and we're not talking about the bumps. We're talking about how close together all those
the lines are. The
Right.
bumps, I mean, that's just a very, that's a whole different thing. But this is where the driver starts beaming.
Okay.
That's when the off-axis performance changes from the on-axis performance.
Okay, and we can see a pretty wide difference beginning at about 600 hertz, but it just gets wider and wider
Correct.
as you go.
And that tells you something. That tells you two things. One, you're getting breakup up here. You're getting some ragged response. You
Okay.
don't want the driver to do that.
So you want to cut all these.
You want to
frequencies out.
start filtering that guy at about 500 or 600 hertz to
All right.
get this out of the running,
Out of the equation.
out of the equation.
All right.
And that's why you have a woofer, a mid-range, and a tweeter, or
Okay,
a woofer and a
cool.
tweeter.
Awesome.
And the impedance curves is what you use to select the kind of components for the crossover.
Okay, well let's talk about what's in the crossover.
All right. There you go.
All right, what is this?
That's a
I
solar
actually know what this
capacitor.
is.
Yeah.
Okay,
Do you?
it's a capacitor.
Most people see a capacitor. That's the one component in the crossover they kind of know. They might not know exactly what it does, but they know what it is by looking
yes,
at it.
indeed.
A capacitor is kind of like a very short-term battery. It's an electrical storage and releasing device.
Okay, that sounds weird. You've got a battery inside your speaker. It makes sense to have storage inside your amp.
Well,
Why inside your speaker?
just like in a power amplifier, okay? When you have the capacitor bank, the capacitor store electricity, and then when the amplifier gets to a state where it needs a little extra help, that filtering capacitor will send extra power to
which makes
the
sense.
voltage
You want energy stored so that if there's a dynamic peak,
exactly.
it can grab it.
So it's a storage and release device.
Okay.
But part of the way it works is it blocks low frequency information and allows high frequency information to go through.
Okay.
It basically stores the low frequency information, and the highs just shoot right through it. So you can use it in relation to a driver to filter.
Driver like this.
Yep.
Okay.
If you put it on the positive.
Okay, so we'll call this one
positive and negative.
Okay. There's
you put it in series. Now, when I call series, that means it breaks the connection between the positive wire getting to the driver.
Okay.
So positive here, and then it goes through. It goes through.
Okay. Good.
So that filters low frequency information, and you use the microfarad rating of the capacitor compared with in relation to the impedance of the driver to know at what frequency that starts.
And we're using this as a generic driver.
Yeah,
because you're not going to use it this way on a
well. Yeah, this big a capacitor, it's going to be low pass and pretty low.
Yeah.
But that's job. It's a high pass filter. What they call it, passes highs.
All right. Cool.
Okay.
But what happens if we do it?
That's
way.
okay. So
that.
if you take that series capacitor and parallel it, that means it's hooked in parallel. The plus minus. It's basically called a shunt at that point.
Okay.
It takes the same high frequency information that would have been delivered to the driver and runs it through the capacitor into the negative side and shunts it. It just goes away.
It just goes away.
Yeah.
All right. Awesome.
Okay.
Cool.
The next component I'm going to talk about is the inductor.
The inductor. Let me see the inductor here.
It's a little heavier.
That's got way more weight to it.
It's a big coil of copper wires, and that's a small one.
Yeah.
I've seen them.
Yeah, they get pretty big.
Yeah. But that's just your standard Janssen audio 4.5 millihenry. 4.5 millihenry is the way they measure it.
Okay.
It's a length of wire cut to a certain length, and that's where they get their millihenry rating, is the length of wire. And it's a coil. So what that coil, the power goes through the coil, and it creates a magnetic field in the center.
Okay.
Electromagnetic field. Okay. And that electromagnetic field is good at passing low frequency information that doesn't change the magnetic field. And it's bad at passing. It does not want the high frequency information to go through it. It doesn't allow it
so
because
this
it changes the magnetic field.
This is going to help you get sound to the woofer without throwing high frequencies to the woofer. Correct? Okay.
And same thing goes.
All right.
Hold the woofer up.
I'll hold this
positives here, negatives here.
Cool.
If you put that in series, it will allow low frequency information and will filter out the high frequency information at whatever millihenry this is.
Okay.
It will do it at that frequency compared, say if this is 8 ohm, it will filter at a certain frequency. If you take that same component and run it like this, it takes that same low frequency information that would have gone to here and runs it over to the negative side and what they call shunts it.
Okay, and once again it gets rid of it.
Okay.
But you're probably not going to want to do that going to a woofer, right?
Well, there's a reason why you don't filter like first order filters, 6 dB, single element filters. It's always capacitor for the highs.
So this is just another capacitor.
Yeah, that's a Janssen silver. That's a pretty high quality capacitor there. Okay. And the inductor, you do not want to just put an inductor like this. It changes things. You want to put the capacitor first.
Okay.
Or the inductor for lows on 6 dB per octave.
Okay. Very nice.
On a 12 dB per octave filter, if you want to go more aggressive with filtration,
you want to get that you want to get that 500 hertz and above.
There's a combo.
To just drop.
Fast. It's the combo. Okay.
So I take this one.
The same thing.
Series.
This is going to filter lows at 6 dB per octave, depending on. And if you match these two to where they're working in the same frequency band, and you put this one in front of that one in parallel, you get 6 dBs here. Then it comes out here, and then it shunts off highs here or lows here as well. And you get shunt off, so you get 12 dB per octave slope. That's why I get the second order. It's second order because there's two filters in line.
Right on.
Okay. I'm not going to go any deeper in the woods than second order because you get the third order, fourth order. It's more components and more complicated.
Now I see this is a resistor. Okay, cool. What's I'll bet I can guess what a resistor does.
The thing about electronic components is a lot of people don't realize is it's called a lot of times what it does.
Right.
Think about capacitor.
Capacity. It holds.
There you go.
Right?
Resistors resist. They resist the flow of electricity. So when you put a resistor on the positive side of a speaker,
I gotta grab my.
I know it. Okay. You should have brought out a tweeter.
I should have brought out a much smaller.
But it's all good. This will impede the flow of electricity to a certain point, and it will lower the amount of output that this driver will have.
Okay.
And that's what you use to match driver output levels when you have multiple drivers in a speaker.
So if I have, let's say my tweeter, let's pretend this is a tweeter. It's like 16 ohms. And I want to drop that. I stick a resistor.
Well, it does change the impedance that the amplifier sees, but it's more about SPL drop. That's what you're focusing.
SPL drop. Sound pressure level?
Yes.
Okay.
So it drops when you put one of these in, and a lot of people what they do is they'll put one in line in series and one in parallel, and that stabilizes the impedance. And it basically the amplifier sees a different impedance. Okay. It tricks the amplifier into seeing a different impedance load, so it drops the SPL output of the woofer.
Gotcha.
So
very good. All right. And as a speaker designer, at some point you're going to say, this is the rating of my speaker, the impedance rating of my speaker. And you're going to take all of this information, add it together in some sort of equation or what? Like what's happening?
No, it's not an equation. There's way simpler than that.
Okay.
You basically get done with your speaker crossover. Everything's installed. You're done. You're buttoning it up. And then you use a device that measures the impedance of the speaker as a whole. All right. You don't have to do all the math. Okay. I do math when I have to, but maths are hard, and I don't have fun doing that. So I'd rather just measure it.
All right. So let's say you've got a driver, or you have a speaker with a lot of drivers on it. So like the line arrays, those are going to have you're going to have to do a lot of fancy wiring, right?
Generally with line arrays, it's a game of parallel and series wiring to get the end impedance that you're looking for. So if you have a 4-ohm impedance you're shooting for, and you have 20 tweeters, you've got to do a setup of series of you might put 4 of them in a series wire, 4 more in a series wire, and then parallel them. It's a game you play to try to get the impedance that you're.
And then one other question about that would be, let's say when you are designing your speaker, like as you go, you kind of have an idea of where you are. Like you're not just at the end measuring it and going, oh, I'm an 8 ohm. Or,
yes,
I'm a
you
4
buy
ohm.
the drivers at a certain impedance to work with, and like a lot of times, like if you buy like your woofers, the woofers a lot of times will be where your impedance comes from because it's producing it's doing the most work. Right. So a lot of times your impedance rating will be in the base. Okay. I'm not saying that the highs won't have low impedance. I've seen tweeters have low impedance, but a lot of times it's rendered with the base. But a lot of times what you'll do is like a lot of speakers, you can run a 4-ohm woofer, say if the woofer's 80 dB efficient. Let's go with that. It puts out 80 dB with 1 watt input. Okay. And it's a 4-ohm driver. Okay. Okay, and you have a mid-range, a tweeter up here. It's a 2-way. You have a tweeter, and it's 98 dB efficient. Okay. So you need to reduce that tweeter all the way down to match this guy. Okay. You don't really, people do it, but I don't like to put resistors on a woofer because resistors resist, and they dissipate power and heat. So what do you think is going to happen when this guy's working his butt off receiving big power from an amplifier and that resistor is resisting? It's not. You have to run really good resistors that handle heat and vent and heat sink well, and you still are taking a chance on frying resistors. So I don't like to do it. So what you do is you pick the driver that has, you pick the base driver that's kind of got the SPL you want to work with, the sensitivity you want to work with, and then go to match it. All right. The mid-range tweeters say, okay, so you have your driver. A lot of the tricks that you can do is you can take a 4-ohm woofer. The tweeter the tweeter can be 8 ohms. And what that does is that automatically reduces the SPL in relation to this because it's an 8-ohm driver. Right. So you kind of can work with different impedance drivers to help you mitigate the SPL difference before you start adding parts. Right. Okay. Very good. Very good.
All right. Well, that's a lot of information about speaker design. Yeah, and it's really helpful actually for somebody that's just curious.
Well, for the buyers of speakers, the biggest part of this is for purchasers of speakers. Okay. A lot of there's been a lot of arguments on speaker design and crossover quality in speakers, and a lot of people worry about that because it's in most of the time crossovers inside the speaker where you can't see it. Right. And some brands out there, and I'm not going to name names because it's doesn't help anybody. No. But some brands out there will put lesser quality parts inside a pretty high quality, pretty high price speaker to reduce their parts costs.
So what you're saying is you could take a nice Jansen, take a nice Jansen capacitor, or you could get a capacitor that's basically the same size, has the same measurements essentially, but it just doesn't have the same quality.
Well, yeah, because this is a polycap. This is a silver polycap a silver capacitor that is high quality.
Right.
You can go off Amazon and buy electrolytic capacitors for pennies on the dollar, and they degrade the sound quality. And a lot of people argue that parts don't matter in a crossover. But when you're putting electricity through this and it's filtering the electricity,
that makes sense.
The better the filter, the better the output.
Right.
So parts quality does matter. And I tell people if you're looking at a speaker brand to buy, try to see if you can find a picture of the internal crossover. Right. And it will tell you a lot. The better you can learn how good parts matter, the better purchasing decision you can make.
Yeah.
The biggest thing I say to people, make sure it's at least got polycaps and not electrolytic capacitors.
I love it when speaker designers have on their website a photo of the crossover. Tells you a lot.
Yeah. Well, they're not afraid to show you.
Right.
That's the biggest one.
Right.
Inductors, there's air core. Have you ever seen the inductors that have the iron bar through them?
Okay, yeah.
That's iron core.
Okay.
Iron core inductors are good for some things, and they're better than these for some things. But for most part, they're way less quality of a inductor than a air core.
So could you use a combination like air core and iron
Most
core?
people that use iron cores do them in very, very low frequencies where ultimate like resolution and stuff is not going to matter as much.
Okay.
But in a mid-range and tweeter circuit, there's not a place for iron
Okay,
cores.
very
Air cores only.
Okay.
Resistors, there's sandcasts, and then there's this type. These are the better resistors to buy. The sandcast does the job, and many will argue that there's no difference. I'm here to say I've worked with them enough that there is a difference, but out of all the parts, that's probably the smallest difference.
The smallest difference. Okay.
Yeah.
Very nice.
Stick with good capacitors. This is a French-made Solon. It's a decent cap. It's not terribly expensive. That's the thing that people don't understand. Good quality capacitors aren't necessarily expensive. Now, you can get deep in the woods. I mean, some of the Jupiters and Doolins out there, you're talking $1,000 a capacitor. And it gets expensive very quick for high quality stuff.
Right.
But you don't need to go that high to get good sound.
Okay.
You just need to choose good quality.
So you're going,
parts.
yeah. So when you have a, I don't know, $1,000, $2,000 set of loudspeakers, they're not using the $1,000 per.
Exactly.
But when you get up in these $80,000 and $100,000,
well, they better
be using that kind of stuff, right?
And that's the thing I want people to check on.
Yeah.
Because I have seen designers use bargain basement components in a very expensive speaker.
Yeah.
So you kind of learning this and the thing is, you don't need to know how to build a crossover to see that it's got quality components.
Right.
Learn what quality components look like and look at and see what brand names are out there in the quality component world.
Right.
And then look at your speaker, because a lot of the speaker designers too like to use some of the Chinese no-name polycaps. Right. And the problem with those are they're still polycaps, but they are very loose tolerance. They're, they say plus or minus 5%, but they might be actually plus or minus 20%.
Right.
And you want to stick with plus or minus 5% or better, just simply because once you get past the 5% change, it can change things compared to what you think you're getting.
And there's probably another question in there about plus or minus 5%, but we do have to keep this to a certain
the biggest thing about plus or minus 5% is when a capacitor is made, like this Solon, it says 130 microfarad plus or minus 5%.
Okay.
That means
it's within 5%.
It's 5% of 130.
Okay.
Going up or down.
Okay.
And the 400 volts is its rating for voltage input. Okay. So it's able to handle 400 volts continuously without failure.
Okay.
Is what that means.
Very good. Awesome. That's a lot of information.
And, it is.
And really, we're doing this for multiple types of people, and for the guy that isn't really technical, some of this may go over your head a little bit, and that's fine.
Okay, so the biggest part for the non-technical people, for the people that want to just buy speakers and kind of know what they're getting,
right?
look at the parts quality of the crossover and see what brand of parts they're using and make sure they're using quality parts.
And if you don't know what the quality parts are, how do you find out what the quality parts are? Do you ask questions, right?
Ask questions. If you see a brand name on a capacitor, look it up. See what the ratings are. See if the builders are using them and if they have good fond reports about them. Another thing is, and for the people that are starting to get DIY with their speaker and want to build speakers, absolutely. This stuff might help them get started and might let them have a little bit less of a hard time getting used to what these parts do and how to use them together to form a quality crossover speaker.
Absolutely. So, and there's guys that are just never even going to look at that kind of stuff. In terms, they're just going to go. Hey,
well, I mean, like you. I mean, you're an ears person. You want it. If it sounds good, you don't care.
And what's really funny is, as an ears person, a lot of times I find out, man, there's a really great crossover network in there.
Well,
and I also have speakers that I'm like I said, when I look at a website, I want to see that they're confident in their crossover enough that they're going to take a picture of it.
My speakers, I would have no problem showing anybody on earth my crossovers because I use only quality components. Right. Yeah. And I would be wary of a brand that wouldn't allow you to see their crossovers because usually if they're not allowing you to see them, they're doing something a little shoddy.
Yeah. Very good. All right. Well, that's a lot for one episode, and I think it's really helpful stuff. So, Doug, thank you. That's just. That I think that helps a lot of people, and it's help that's really kind of needed.
Yeah. Well, I mean, it's kind of the thing that probably certain people in the industry don't want you to know this kind of stuff, but I'm one that doesn't. I'm not scared to let people know.
Right on. Well, I think our next episode we're going to do is going to probably be on switch mode.
Switch mode versus linear power supplies, which is a whole different subject, and it's one that needs to be talked about because there's a lot of old information still being spread around about the difference.
Old school guys.
Linear
are talking
linear,
and other guys are talking switch mode, and it's kind of a debate.
It's a debate that needs squash because switch mode power supplies are so good now that there's hardly any difference.
We'll get into that and dig into the weeds a little bit with that the next time. So we'll see you guys next time on Signal Paths. I'm Ryan, and he's Doug. All right.
Thank you.